All right, block 3, my favorite class of the day. Hopefully, Mrs. Huss figured out how to get the video of me working here. I'm not going to do this the whole time. I just wanted to at least have a little bit of contact with you guys today. So, you didn't have a bell ringer. Right now, what you guys need to do, Mrs. Huss, get ready because you'll pause the video here. What you guys need to do right now is move your desks around. You don't need to go to the lab. You're gonna get together. Your graphs should be completely done. If you're all done with your graph, I want you to open, you guys can see up on the screen here, my phase change of water lab. Now, you need to go finish this. So what I'm highlighting here and writing in red, you need to go finish, okay? So you guys look at what we wrote. So we wrote until it was completely solid. The test tube will be removed. And what you probably should go right here on your procedure is we went and graphed it. You can go talk about what we graphed where and how you connected the dots, and that will finish up your procedure. So for right now, why don't we take 5 minutes or so. Mrs. Huss, if you could pause it. Everyone needs to finish their graph. David, I think yours is up on the front board magnetized, and everyone can finish writing out their procedures. And then as Mrs. Huss gets ready to unpause it, she's going to bring around a piece of paper that says conclusion questions, and we're going to take about 10 minutes and you're going to start working on that, okay? So don't do it until everyone's ready, Mrs. Huss, and first make them go get together with their partners. So pause the video, finish the procedure, make sure your graphs are good. Everyone get to work right now. All right, so everyone kind of come back together here. Everyone please have your graph out in front of you, okay? So Mrs. Huss, make sure everyone's kind of getting situated. And what you guys are going to see, so I'm going to have some old stuff here. If you guys all look up on the screen, this is a former student I had. This is her data table. It's very, very nice and organized. You guys did that on your computers. Since it's 2021, we're trying to be more technological. And now this young lady, if you guys look, did 2 different graphs. She kind of spread it out a little too thin. So I'm going to kind of zoom this open here, but everyone kind of look up on the screen here, and I'm going to zoom in just a touch if I can. If you guys look on her graph, it looks a lot like yours did, okay? So hopefully here, oops, I don't even need that on there. Everyone needs to kind of look and talk with me here. So I want everyone to look. What did your graph start at? If everyone looks, it should be around 15 to 20 degrees up here. Now, we put it in the hot water bath, and then what happened? The temperature went down, the temperature went down, the temperature went down, and that makes sense. Since we put it in the ice, we know that we were removing energy from it, and that bonds were starting to pack in there and form. But then you guys can remember from yesterday, on hers here, this is Bailey's, she had a big flat part, and some of you guys said this is where my thermometer's broken, but we now know that our thermometer wasn't broken at all. So right now, Mrs. Huss, I want you to pause the video. I want you to make the class talk right now for 1 minute. Why didn't the temperature keep dropping when it was in the ice bath? It should have kept dropping. Everyone, please pause this video and discuss right now. Mrs. Huss, go ahead and pause it. So, Xavier, Gavin, I'm sure one of you guys were on the right track. Why don't you share with the class what you got? Mrs. Huss, feel free to pause again. But I'll go ahead, and I'm sure, Gavin, that sounded great. I'm sure. Jackson, put your phone away. I'm guessing. If we look right here, guys, this is the really important part. This is where our water in the test tube started to freeze. Now, with that being said, that is a phase change because we're going up here, it was a liquid. You guys know down here it was a solid. So that means right here, when the temperature wasn't dropping, what was happening? Why wasn't it dropping? The reason why is because the water molecules here got to the point where they weren't moving very much and they started to form bonds. When it leveled off down here, the temperature wasn't dropping, the temperature was staying the same because we were forming bonds, okay? So if we need to pause and make sure, you're going to talk about that in your conclusion, and there's a bunch of conclusion questions that talk about during a phase change, temperature stays the same. Now, if you look at Bailey's graph here, this was just the first part. So right now up on the screen, I'm also going to pull up the second part of her graph. And you can see it continued on at 0, it continued on at 0, it continued on at 0. And a lot of you guys, this would be after you took it out. So it rose back up to 0, and it stayed the same, and it stayed the same, and it stayed the same. And some of you guys even were warming it up in your hands But why isn't it getting hotter? So Mrs. Huss, if you could you please pause the video and guys think about the molecules. Why, even though, I mean, there was solid chunks of ice in here and we know it melted up here. Why, even though we were heating it up, why wasn't the temperature increasing and what were the particles doing? Go ahead and pause it, Mrs. Huss. Everyone, please discuss with your partner. So, this is going to sound familiar, guys, but whenever the temperature, hopefully everyone's back at here, focus with me. When the temperature's back here, it stays the same and it stays the same even though we are heating it up. This is actually exactly what would also happen if we were heating up a pan on the stove. The main reason is even though I'm heating it up and heating it up, the particles aren't moving faster because otherwise the temperature would be increasing. So if it was a solid way back on Bailey's other picture here, if it was a solid and a solid and a solid, the reason here all of a sudden it levels off when we warm it back up is because if it's a solid over here and it's a liquid over here, I gotta break the bonds, I gotta break the bonds, I gotta break the bonds, I gotta break the bonds. And over here, all the bonds are now broken. So now I can speed them up and make it a liquid. So the most important thing you guys need to take from this is the fact that when a phase change happens, whether it's freezing or melting or boiling or whatever, the temperature will stay the same because we either have to make bonds or break bonds. All right? So with that being said, why doesn't everyone take a 1-minute break, get up and stretch, and I have 2 more things I want to hit with this video. So Mrs. Huss, if you could pause it. Everyone get up, stretch, take a quick break, and we'll finish it here. All right, so everyone bring it back in, get focused, have your graph in front of you. You guys are going to get a lot of time to work after this, but the other thing I want to bring up is this, okay? This is the first part of our curve when we have a liquid at the beginning. What would we call this temperature right here? And if you guys look, our thermometers are not perfect, but if you look, it leveled off at 0, it leveled off at 0, it leveled off at 0, leveled off at 0, and this is when we went from a liquid to a solid. So everybody, what's it called when I take a liquid and it phase changes into a solid? I'm gonna wait a minute here. Everyone talk it over. What would that be? If we have a liquid and it becomes a solid, that's called freezing. So everybody, it's really important you guys note the freezing point of water is what? That's this leveled off phase change that is around 0 degrees Celsius. Now, a lot of kids will say, well, in the winter, I always worry about if it's 32. So maybe Mrs. Huss, pause this quick, everybody. What does 32 have to do with water freezing, and why does it say 0 here? Pause it quick and everyone go talk. Okay, now unpause it. So everybody, what's the reason? The reason is because we live in the United States and we're kind of dumb about the way we use units. We usually do our temperatures in Fahrenheit. So if you went to the rest of the world, they all care if it's going to be icy on the roads about 0 degrees because the freezing point of water is 0 degrees Celsius. The freezing point of water is 0 degrees Celsius. And that's how Celsius was created. It was created for water. Now on the flip side, if I look at the rest of Bailey's graph, after we took it out right here, this is where I had a solid, and I'm going to zoom in. I had a solid and then it warmed up and then it stayed the same, stayed the same, stayed the same, leveled off, and then it became a liquid. So everybody, what is the name of the phase change when I take a solid and it melts into a liquid? Go ahead and talk that over. What would that be called? Vinny, what's the answer? Presley, do you know it? Bryce, back there? That would be called melting. When we go from a solid and break the bonds all apart to become a liquid, we're melting it. So everybody, what's really weird here is look at your graph, look at my graph. What's the melting point of water? If I have a block of ice and I want to melt it, what temperature is that? What do you guys think? That is also 0 degrees Celsius. So it just so happens that if I want to freeze things, that happens at 0. If I want to melt things, that happens at 0. So what's the difference? The difference is that for one of them, I'm taking energy out and slowing particles down. For melting, I'm taking energy and putting it in. That really should help you answer most of your conclusion questions. Just make sure you guys are thinking about temperature is average kinetic energy. It's a measure of how fast particles are moving, all right? So with that being said, why don't we take about I have one last thing here, but then I want you guys to take 15, 20 minutes. You're going to work on your conclusion questions that Mrs. Huss gave you. Okay, there's going to be a little graph at the bottom. And then on the back side, there's a completely different graph of a new substance, okay? So we got to really do some practice with this whole idea of phase changes. And the thing we have to do, I know you guys all know what a phase change is. We need to understand what's happening to the molecules, okay? The molecules are the most important part. If I go back to my original picture here, if I go look at this bad boy, you guys got to think about, well, if the temperature is going down over here, particles are slowing down, less and less energy. If I go on this graph right here and the temperature is going up, I'm making the particles move faster. If the graph is level, motion is staying the same. The particles aren't getting faster or slower because that's what temperature really is. All right, so with that being said, this video is almost done. Mrs. Huss has your guys' conclusion questions. You need to do the backside that talks about application questions. When you get done with that, you may take a break. You need to turn it into her. Then Mrs. Huss will give you, you're going to have a couple conclusion questions you're going to write about. You'll do that on your phase change of water lab. Make sure this is all nice and neat. And if anybody ropes through all that stuff, your final assignment will be a worksheet Mrs. Huss has called the heat curve of materials worksheet. That's all. Tomorrow will be a short day on Friday, but I expect you to get this all done. I'm giving you guys time to work, so please put your phones away and please be productive. We're probably, hopefully, trying to break the record right now at the track meet when you guys are watching this, so cheer loud, go Tigers, and get your stuff done. Help each other out if anyone's struggling. I'll see you guys tomorrow on Friday. Mrs. Huss, this is the end of my video.